Hello everyone, my name is Dr. Satyanarayan Rao. Welcome to my video, and today I want to talk about the basic mechanics of a train or a rigid body that is actually relevant to train travel. And I have been traveler myself, and I have traveled in trains in many countries including in India, in Germany and other places. And I have noticed that especially in the newer trains in Germany, they provide a very smooth ride. So in this video we will understand the basic forces and why the newer trains are smoother as compared to the olden trains. So to understand diagrammatically, I'm drawing here a rectangle that actually represents the coach, and there is track at the below, and you have the wheel section that is actually connected to the rectangle. And when you don't have any of the shock absorbers, whatever forces you get from the track, it's directly transmitted to the coach like a bullock cart, and you feel every bump and every forces that is happening below you. And in the old days we just had two shock absorbers, that was in the vertical direction, that is similar to our personal cars, where we can have like all the vertical forces when we ride on a hump. These are actually absorbed. For example, when there is a change in the elevation, the tracks also have bumps or some change in elevation, or when there are two pieces of track and there is a small gap, that is what makes these noises. And these vertical forces was absorbed, but there are actually other forces. There are also lateral forces involved. They cannot be absorbed by these vertical shock absorbers. So for example, when the train is going along a curve, you do have centripetal forces, and these actually create radial torque that actually pushes the coach in the sideways direction. And so what I have observed is that the newer trains have additional springs or shock absorbers that I am showing here, which tend to absorb these sideways forces as well. And that's what is making the train ride so smooth. And not only that, we also have the roll and yaw. The roll is the rotation around the longitudinal axis, while yaw is the rotation around the vertical axis. These rotational motions occur because the coaches have a rigid structure. So when there is a sideways, when the one track is higher than the other track, let's say the left track is higher than the right track, and this will create a kind of rolling forces on the coach. And we also have yaw, which means for example, the front tire of the coach is slightly leftward as compared to the back tires or the back wheels. So this will also create a rotation along the vertical axis. And so these are different forces, and these side shock absorbers that I am showing here, actually they absorb not only the vertical forces but also the lateral forces, and these actually help control the rotational movements as efficiently as possible. And that's the reason I can drink a coffee peacefully without the fear of spilling it. It's like literally the coaches are actually floating around the wheels. So that's why these trains have very smooth ride. So now let's look at these forces mathematically. So if we consider the vertical forces, they have like two main components. One is the gravity, and the train has the mass in the coach in which we are traveling. So that is a downward force that we can write it as mg. And there is also a reaction force coming from the track in the upward direction. That is what we feel the bumps. And we can write it's because of the track irregularities that we can write it as F reactive, that's actually coming from the track to the upward direction. And when we see this is what we see when the train encounters a gap between two track pieces or elevation changes. There is some force coming from the earth towards the passenger seat, and these actually aren't related to the train's forward acceleration. For the train forward acceleration or deceleration, there are other springs between the coaches. Even if you are flying and if if you accelerate or decelerate, you would feel forward or backward forces. But we are just understanding all the forces between the earth and the coach as a single coach, if we can consider. We have the lateral forces that actually you feel it pushing you in the sideways direction because of the centripetal force, that we can write it as Fc as mv square by r, where this r is now the radius of the curvature of the curve of the track, and actually this is what is causing the sideways pull. Actually, that is actually proportional to the square of the train's velocity and inversely proportional to the radius of the curve. And so it means that the tighter the curve or the faster the train, we will have these forces become much stronger. And as I already explained, we also have roll and yaw, which we can write it as in the rotational format. It becomes now the torque instead of force. We can write it as tau as I times alpha, which is the mass becomes moment of inertia, and the alpha is the angular acceleration. So it's something similar. So we have this another force, that is the roll and the yaw, because of the things that we discussed. And so together what we have is, we can write all these forces, we can combine it to become to write it as F disturb. So this is the disturbance forces that is actually coming from all directions that makes our ride discomfort. And why keeping shock absorbers helps is because, so according to Hooke's law, the person who named who discovered this law is the Robert Hooke. So we can write Hooke's law as, because the shock absorbers are basically the spring, the F spring is written as minus kx, where k is now the spring constant, and because we need work to compress the spring, that's how the spring constant k is carefully engineered such that it actually subtracts all these F disturb, the force that is causing the discomfort while we are traveling in the train. So the modern trains, actually the suspension is designed in such a way that it integrates all these forces, the vertical, lateral, roll, yaw, all these things is designed in such a way that it's totally subtracted, or it's minimal. But these are not actually springs. These modern trains actually have hydraulic dampers, where the damping, but it takes the same format. Actually, this helps. All this energy is actually has to go somewhere, and it actually dissipates as heat, or it doesn't transfer. All this kinetic energy is actually transmitted into the shock absorbers that actually converted into heat. And that's why we experience a smooth ride, because the springs are designed, or the shock absorbers are designed to counteract and absorb all these forces. This is actually a simplified way to understand rigid body dynamics as it applies to the trains, but it actually involves much more complicated physics, like the structural integrity of materials, how we design. If we have observed, the train coaches are slightly triangle at the top, because we want to lower the gravity, the center of gravity, and air resistance, aerodynamics, a lot of other things are involved, but this was a simplified way to understand train dynamics. And thank you for watching. See you soon in another video. Till then, keep learning, enjoy life. Thank you.